Welcome back to Python Noob. This is GOS, and today we'll be going over functions and modules. And before I get rolling, hit the like, the subscribe, comment, and let me know what you think of the series so far. All right, let's get rolling. So functions and modules. Now we will discuss how to create code blocks that can be reused anywhere in the program, called functions and modules. They are useful tools that can make your code much more efficient and quicker to write. Functions are pre-written blocks of codes that can be invoked later to carry out code within them. Variables and functions used in a script can be saved and exported so that they may be used in other scripts and programs. When saved for later use, this is referred to as a module. So a predefined function that we've dealt with before is the print function. We will learn to write and use our own functions. You can call functions in multiple ways. Most intuitive way is to simply use the function name followed by the parentheses. Typing out the function name will typically invoke a function. You can use dot notation, meaning placing a period before the name of the function. Dot function underscore name parentheses. Used to tell Python you want to call a function on a specific object with name of the object just before the period. Target underscore object dot function underscore name parentheses. Sometimes we need to provide a function with certain variables, data values, called parameters arguments. The parameters arguments are passed to the function by putting them within a set of parentheses that follows the function name. When passing multiple arguments to a function, separate the individual arguments with commas. An example of passing arguments to the function is the print function. To pass multiple arguments, you separate by commas. So creating your own functions, you can use the define or def keyword, which tells Python you want to define a function and that it needs to recognize a variety of keywords and values to follow. Then you need to provide the function name and any arguments, parameters your function will use. You can begin writing commands you'd like your function to carry out. As an example, def name parameters in parentheses, and then the colon, don't forget the colon, and then the code to carry out the desired actions in the next line of code. Your functions will often require the return keyword, which specifies an expression variable value you would like the function to pass back out to the main program once the function has finished running. Once the return statement is executed, the function will stop running and the expression you've designated will be passed back. An example is def name parameters, code to carry out desired actions, and then return the desired expression. That'll make more sense as we actually practice writing actual code. If your function returns the value, you can assign to a variable by calling the function and assigning it to a variable. You can then manipulate the return value. Return value equals function used, list of parameters. So if your function does not need to return a value, you can either just not use the return keyword or use return none. An example of a function that you can run in PyCharm. So I wrote it here on the right, and then this is our output. So define multiply values, number 1, number 2, and then you're setting number 3 to equals 2. So you're printing number 1 is, and then plus string number 1, which means you're converting whatever the numerical to the string. And then number 2, same thing, number 3, and then multiply number equals number 1 times number 2 times number 3, and then you print the product of multiplication is plus string multiple number, and then you return the multiple number. So you have 8, 9, and 2, and then the product of multiplication is all these multiplied together. You get 144. So it takes in two different numbers as parameters, multiplies together, then multiplies the product of those numbers by 2. And then it returns the multiplied value. It also prints out the numerical values that have been passed in, as well as a product of multiplication. Creating your own, Okay, so we can now call the function, assign it to a variable, and then print the variable to make sure that the return value is what we expect it to be. So multiplied equals multiply values, and this green underline just means I have something wrong with my PEP 8 guideline. I don't think there's any actual code wrong. And then you print multiply, and it'll bring back obviously 144. If we declare a new variable, which is number 4, outside the function, this variable is global and can be printed. You could pass number 4 to the function when you call it, and the function would be able to use it as it is a global variable. So an example is here on the right. We've defined number 4 right here, and then you print number 4, and that'll give you 12 on the output. It's important to understand the difference between local and global variables, especially if they have the same name. So basically, local variables is anything in this block of code that's been indented. That's going to be this separated code block right here. And we've defined number 3, for example. We can't call number 3 outside of this block. If we try to call it, print number 3 right here, it'll run this error, the name error. But if you define number 3 outside of this block, that becomes global, like number 4 here. So you can actually call that in anywhere else in the program. So variable scope, it refers to the visibility, accessibility of variables. Variables can only be used by Python if they are in the correct scope and if the program can see the variable at the current point in time. Variables declared inside a function are part of that function's scope, and they are handled differently than the variables created outside the scope of the function. The difference is that variables created within a function can only be used inside that function, not accessible by the program at large. It's called local. Variables declared outside the function are global, can be accessed by the entire program. In the previous function, if we try to, like I explained in the previous slide, if we try to print out number 3 variable, it'll cause an error. It is a local variable, and a name error is thrown. So default parameters. Python allows you to specify default values for parameters that will be used in a function. Default values are useful because they enable the program to run without needing to pass the values for all parameters at the runtime. In order to create default values in a function, you can use the assign operator, an example, and as you see here on the right. So we define the sample function, variable 1, and then variable 2 equals 9. So then you print variable 1 is plus string variable 1, and then print variable 2. And then sample function 12, 24, wait, no, it shouldn't be this one. It's this one at the bottom, sorry. Okay, so yeah, we sample function 12, which makes variable 1 12, and then variable 2 is equal to 9, and that will be your output. Yeah, so running this code, you will discover the value for variable 1 is 12, as specified when the function is called. Variable 2 is 9. We can overwrite the default value simply by passing in a value for the second parameter. And that's what we did right here. So variable 1 will still be 12, 24 is going to be 2, I believe. So variable length arguments, lists, and keywords are star args and double star kwargs. What can we do if we don't know how many arguments a function will need? Python allows us to handle situations like this by using variable length argument lists and keyword argument dictionaries. Variable length argument lists passing an empty list into the function, a list that will be filled in with values as the program's running. Let's assume you have a database full of sentences. However, you don't know how many sentences there are in the database. So this is how you define it. Define print sentences star, which is just an argument, sentences. For sentence and sentences, print sentence. The advantage of using a function like this is that you can just add sentences straight to the function call as parameters without having to alter the way your function works in any way. The star symbol tells Python that it should be prepared to work with an unknown number of arguments passed in a list. An example is print sentences, sentence 1, sentence 2, sentence 3. The asterisk declares a list that will vary in length that will be passed to the function. We can also do the same with keywords instead of non-keyword argument lists. In order to use a variable length keyword dictionary, we would declare the argument dictionary with 2 asterisks there. Assume that we have a large dictionary of contact information containing names, email addresses. We want to print out both the key, the name, and the value, email. Example on the next page. So we have it down here. Define print emails, double star or double asterisk, emails for name, email, and emails, items, and then empty parentheses. Print name equals curly brackets, email equals curly brackets, and then format name, email. We can use our function by calling it and passing in games and emails in keyword assign format. So in this format right here, you're assigning email 1 as a variable to test at email.com. Print emails dictionary information here. Functions above were written with sentences and emails as the names of variable length argument lists and keyword dictionaries. They could be anything. When you have these concepts in your own code, you are encouraged to stick to Python convention and use star args or double star kwargs as their names. If your function utilizes any combo of regular arguments, star args and double star kwargs, the parameters must be declared within the parentheses in specific order. The regular argument must come first, and then the star args, and finally the double star kwargs. So importing modules. Python's built-in functions, print, parentheses, and is an example. It's a part of the standard Python package. In contrast, some additional functions come with a Python installation but aren't available for use until you import them. These functions are referred to as modules. To import a module, you can use one of several different import methods. Import the name of the module. And Python comes with a module called random, used to generate random numbers, so you import random. When you import a module with the above method, in order to use a function that the module possesses, you need to call the function using dot notation. In order to make use of the range function that's built into random, you use the following syntax. So import random, as you see here at the bottom, random numbers 2 equals r dot range, and then 025 is the numbers that we selected. You can also shorthand or nickname a module that you import so that you don't have to write out the name of the module each time. For instance, we can alias random like this. You import random as r, as you see up here. We can now call range function simply by simply writing this line right here, line 2. We can also import specific functions rather than import the entire module. We can import specific function by specifying the name of the module with, from, and then using import keyword with name of functions we want to import. From random, import range, like we talked about in the previous episode. Importing a specific function this way enables us to just refer to the function by the name when we want to use it. So random underscore nums 3 equals range 025. You can import multiple functions from a module by separating the name of the functions you wish to import with a comma. In general, it's best to import specific functions instead of the whole module because it can slow your program down if you import too many modules. After you create your own functions, you can package them into modules for use in other programs and scripts. Creating modules out of functions that you commonly use may save you a lot of time, as you can just reuse them for future projects. All you need to do is make sure the file is saved in py extension, ensure the file containing the function is in the same folder as the file you're importing the function to. An example, creating a function that will join multiple input phrases into a single string. Let's see. So we're defining args to string right here, and this is the function that I saved as just args to string, as it says right here. And then I imported it into another file that I created, and Yeah, and then you ask, well, then you define string one as args to string, which it combines all these, and then you print it, and it should print all of them together as a sentence. You may have to use a function that is in a dictionary. You can use the system module, which enables Python to change where it searches for files. Let's assume you have a file called Python programs saved on your C drive. You can simply use the system module to include that folder as part of the path. The list of directories that Python will search when looking for files, you import sys, and then sys path append, which means adding to C and Python programs. Including these commands in your program would be enough for Python to be able to find the arg to string py file extension. So useful built-in functions and methods. The functions below are all built in to Python and can be called simply by invoking them with no imports needed. Also included methods, which act like functions but only work on specific data types and structures. Methods are typically invoked using dot notation on target objects. So the print function, that's actually supposed to be ABS, absolute value. That's a typo. But round, you are rounding the number that you put in there to the nearest integer. Minimum finds and returns the smallest value or the earliest alphabetical character in a list. Maximum, largest value or latest alphabetical character in a list. Sorted sorts the list in ascending order and works on both numerical values and strings. Sum it adds the elements and returns the sum. Len counts and returns the number of elements in a list. On a string, it will return the number of characters in a string. Type returns the data type of variable. So in terms of string methods, lowercase, we talked about that in a previous episode. Uppercase, strip, we haven't talked about this one before. It removes extra white space from the beginning or the end of the string. It replace, it takes two arguments and replaces first string with second string. Split takes in a specified delimiter as an argument and splits the string on that delimiter. It splits the string into a list, basically. Join joins the elements of a list into a single string. So basically these two are opposite of one another. List methods, append and remove, we've talked about those before. Count, it returns the index number of a given list and a given value in a list. Clear, it removes all elements from a list. Dictionary methods, you have keys, which gives all the keys found in the dictionary. Values gives all values. Clear deletes everything from the dictionary. So our exercise today is we're going to write a function that takes the arguments and manipulates values of those arguments in some way using the star args and double star kwargs. Return the result of manipulation. Use the local variable in the function. Save the file of your function. Save the file your function is in within your current folder. Create a new file. Import the function from your original file. Create some global variables and pass them into the function. Print resulting value of the function. Let's write our own code. Okay, let's open up PyCharm. All right, so the first step is to write a function that takes the arguments and manipulates the value of those arguments in some way, and we got to use both the star arguments and double star kwargs or keyword arguments. So let's see. And I finally kind of figured out how to create a list. This didn't come out perfectly, but so I wrote a function that takes arguments and manipulates the values of those arguments in some way. Define the carbonates, the location of the carbonate, and then the rock body. The carbonates equals in brackets. For I in rock body, print whatever I add to the list, and then format I, which I means item. Carbonates append string location, which is El Paso, plus minus string I, whatever I input into the function. I return carbonates back to the program, and then save the file as carbonates.py. And then I created a new file. I imported the function from the original file. and it's called ploppers. So from carbonates, import carbonates as C. I just shortened it to C. And then carbonates list equals C. And then El Paso is the location. And then these are just a bunch of different carbonates that we have in the area. And then I just printed the resulting value of the function. And as you can see, it gets me El Paso Las Cruces here at the bottom. It added Las Cruces to the list. Yeah, so we'll do the book's example now. Let's try running it. So we are adding bread to the list, and then we added ram to the list. So for some reason, it only adds, the first two. Yeah, I'm not sure why it just adds two. Maybe it's a code issue somewhere. But I mean, we still get an output of adding bread to the list, adding ram to the list, Hilltop Grocery bread, top computer parts ram. Yeah, you would probably have to add each one individually to the list to get this. But yeah, I mean, that works. All right. So thank you for watching. Next episode, we'll be covering object-oriented programming, part 1, classes and instances. Please like, share, sub, comment, all that jazz. Thank y'all.